All right, you guys, this is a big one. Uh, Not big as it shouldn't take too long, but it's important as we move forward. So this idea of discrete versus continuous functions. Discrete, in layman's terms, essentially means kind of broken up. It has breaks in the graph. Continuous means what I like to say is I can draw my graph without picking up my pencil. So continuous, there's no breaks. Discrete, there's breaks. It's isolated. Infinite has infinitely many numbers. So another way to look at this, no, that's pretty much it. Yeah, that's it. All right, so example one, determine if each set is discrete, infinite, or continuous. So this infinite thing, I'm sorry, I didn't talk about this. Infinite, so if I were to list, so like something that's discrete would be 0, 1, 2. Right? That has a very set number of things. Infinite would be if I say, like we were doing in the last one, everything from 0 to 2. Right? So from 0 to 2, there are infinitely many numbers, right? So there's 1.9, there's 1.99, there's 1.999, there's 1.9999. Right, there's 1.6, there's 1.67, 1.63. You can find infinitely many numbers between 0 and 2. So if it includes things between them, so look for interval notation, kind of like part B is down here. Look for interval notation to see if something is infinite. If you see interval notation, even if it's just between here, there's an infinite number of distances between my two hands. There's an infinite number of distances between my two hands. There's an infinite number of distances between here. Right, so you can determine like this is a different distance than this. This is minutely different from this, even though I didn't really move that much. But it's just it's a very this can change very slightly, but it's still a part of this set. All right, so determine if each is discrete, infinite, or continuous. So 5, 6, 7, 8. It's isolated, so this is already discrete. Here, I'll use D for discrete, I for infinite, and C for continuous. This is also not infinite because it's not saying everything between here. These brackets just mean that we're including only those numbers. All right, part B, from 2 to 7. Remember, take note, D means discrete, I means infinite, C means continuous. So from 2 to 7, this is continuous, because there are no breaks. It's not saying it's not including a number from 2 to 7. So it's continuous, whatever the graph may be from 2 to 7. It could be something like that, but I only did it with one stroke of my pen. I didn't have to lift it up at all. So this is continuous. This is also infinite because it's including everything between 2 and 7. All right, part C. Notice these ellipses right there. The ellipses just mean that this keeps going on forever and ever. So that automatically makes it infinite. Can't tell what that is. Infinite. This is also discrete because it has a bunch of breaks in the graph. So infinite and discrete. From negative 12 to 7, not to 7. Notice I almost messed up. These little brackets just mean it's negative 12 and 7 that are included. So this is discrete and it is not infinite. That's the only thing it is. So here, it's everything from 0 to infinity. That's interval notation because of that bracket right there. So this is continuous. This is also infinite. There's no breaks from 0 to infinity, so it could be a graph something like that or something. 0 to infinity, it is continuous and infinite. Then we have negative 2 to 19. This is also continuous and infinite. It's everything from negative 2 to 19. Right? It can be anything in there. It should be open circles. All right, moving on. So the next thing we're going to talk about is something we call parent functions. Parent functions are just the most basic form of the functions. So if I want to graph y equals x to the third, if it helps you, make a little t-chart off to the side here. I'm going to go from negative 2, negative 1, 0, 1, 2. So if I do negative 2 to the third, remember that just means negative 2 times itself 3 times, right? So this is negative 2 to the third. That would come out as negative 8. If I do negative 1 to the third, that will come out as negative 1. 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. 2 times 2 times 2 is positive 8. So if I graph these points, they're going to kind of create a curve, which is really pretty cool. It's pretty cubic, but it's called your cubic function because we are cubing the numbers. All right, so if I follow this function as it goes, it almost looks like a parabola-ish that's been like half of it was turned upside down, but it grows a lot faster because we are cubing it and not just squaring it. All right, so there's your cubic function. The reciprocal function, which we talked about a little bit in the last video, is 1 over x. So again, if we make some values, if I have like -2, -1, 0, 1, 2, 1 over -2 is just -1/2. 1 over -1 is -1. 1 over 0 is not possible. That is undefined, so that actually will not have a value. So remember, you cannot ever divide by 0. 1 over 1 is 1, 1 over 2 is 1/2. So if I graph these points, right, even if I did like 1/2, that's going to create 2, and -1/2 will create -2. So what's happening here is as I go this way, it's getting closer and closer and closer to my y-axis, and as I go out in the positive direction, it's getting closer and closer and closer to my x-axis. Same sort of idea in the other direction. Closer to the y-axis, closer to the x-axis. That is our reciprocal function. We also have something called asymptotes right here. So if they ask you, these are called asymptotes, asymptotes. There's one at x equals 0, which is the one going straight up and down. There's also one at y equals 0, which is going straight left and right. We're going to get a whole unit later on about these functions in particular and how we move them around as well. Just a sec, I got to go yell at my dog. Just being a butthead and barking at nothing. All right, moving on. Exponential function. What, now you're going to act like we're friends? We're not friends. I own you. It's funny because it's true. All right, so if I do -2, -1, 0, 1, 2. That's right, you lay down and pout. Gosh, she lays so weird. Her legs are just like sprawled out behind her. Weirdo dog. It's crazy. All right, anyways, I'm sorry, I keep getting distracted. So if I do 2 to the x, anytime you see an x in the exponent, that's what makes this called an exponential function, because our variable is in our exponent. So if I do 2 to the first, I'll start there. 2 to the first is just 2. 2 to the second is 4. Even if I go to 3, 2 to the third is 8. All right, so if I graph those points, 1, 2, 2, 4, 3, 8, all right, we're creating something like that. So it's creating a curve up. So notice, as I'm going out, it's multiplying by 2 each time. So as I go backwards, it's actually dividing by 2. So 2 divided by 2 is 1. 1 divided by 2 is 1/2. 1/2 divided by 2 is 1/4. Right, so it's getting smaller as we go in the opposite direction. Don't forget negative exponents, that also flips it. So this is really, if I put in -2, 2 to the -2 is the same thing as 1 over 2 squared, which is the same thing as 1 over 4. We'll use that as we get later in this course as well. So that's there, and that's there. So as it goes this direction, it is growing. It's getting huge. As it goes this direction, I'm actually getting closer and closer and closer to 0, but it will never actually touch 0. So even if I do 2 to the -10, right, 2 to the -10, that just means that's 1 over 2 to the 10th, which is 1 over, oh gosh, what's 2 to the 10th? Is that 512 or something like that? I don't know. I am curious now, though. Did I guess it right? No, I was close though. 1024. Because if you double 512, you get to the 9. All right. Anyways, so that would be 1 over 1024, which is still not 0. So it's going to get really, really close to 0. So this one actually has an asymptote if they ask you about it. asymptote at y equals 0. It's going to get closer to y equals 0, but it's never actually going to touch it. All right, let's see what we got on the next page. we have determine the domain and range for each function. All right, so with this one, for a lot of these, I can just think about my parent function. If I see a polynomial like this, it's just the highest exponent that I really pay attention to. All the other stuff, yeah, is important, and you can graph it in your calculator, but my guess is it's going to look something-ish like that. Really, for the domain and range for this one, for the domain, all I need to know is that it's going left and right forever, so negative infinity to infinity. Done. For the range, it's going up and down forever, so negative infinity to infinity. Right, that's it. All right, 3 to the x plus 1. This is one that if I think about it, it's my exponential function, so it's going to be going something-ish like that. So I'll probably want to check this one in a calculator. So if I do, go to my way it equals 3 raised to the x plus 1, and I graph it. So notice here, it's not getting closer and closer to 0 on this side. It's actually getting closer and closer to 1. That's because this plus 1 right here, all that does is it moves your function up 1. So for our domain, it's going left and right forever from negative infinity to infinity. And for the range, it's going from 1 to infinity, so it's going up forever. So now notice, I did not include that 1 because remember, it's not touching it. It's just getting really, 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 really close to 1. Sorry, I had to help my wife unload the car. All right, so in this one, I have 2 over x minus 4. So notice I have my variable in my denominator. So I know that it's going to look something like my reciprocal parent function. And so what actually happens now, if you guys want to know what I'm thinking about when I see these, I see this minus 4. And what that minus 4 does is actually takes the function and it moves it to the right 4. So I go 1, 2, 3, 4. That's my new asymptote. So I know it's going to look exactly like that. But if you don't believe me, put it in your calculator. So here, just be careful typing it in. We have 2 divided by. Now I'm going to put parentheses around the x minus 4 so that it is dividing, that 2 is being divided by both x and minus 4. So 2 over x minus 4, put the parentheses such that your x minus 4 stays in the denominator. So if I look at the graph, well, it's exactly like Mr. Blake said. Oh my gosh. All right, so for the domain and for the range. So for the domain, it has everything except for 4. 4 is not possible because if I had 4, I'd be dividing by 0. So I have everything from negative infinity all the way up until 4, and then from 4 to infinity. Notice I put the union sign in there to say it's in this or it's in this set. Now for the range, it didn't move up or down. So remember we had a horizontal asymptote, y equals 0. And you see it's getting closer and closer to 0 in both ways, but it's not actually touching it. So I have negative infinity to 0, and then again from 0 to infinity. There's our range. All right, this one, I don't even need to really do it. So again, I notice I have an x cubed, so I have a cubic function. Doesn't really matter what it looks like. It might look something like that, though. So for the domain, negative infinity to infinity, it's going left and right forever. For the range, it's going up and down forever, so negative infinity to infinity in that direction as well. Cubics are the best. All right, exponential now. And this one's a little bit tricky, so you may want to plug this in. So we have a negative in front of this, which is going to flip it over the x-axis, so it's going to be upside down. And then we have minus 3, so that'll move it down 3. We'll get to more of like how to shift these things around too in a little bit. Not in a little bit, I think in a few lessons. So we have negative 4 to the x, and then minus 3, so down 3. When I press graph, it will be flipped upside down, and it has moved down 3. So now, for the domain and range, for the domain, it's going left and right forever, so it's still negative infinity to infinity. Now for the range, notice the lowest possible y value on this thing, it's going down forever. So I'm coming from negative infinity, and I'm going all the way up until it looks like it's negative 3, when it kind of bottoms out and it gets closer and closer and kind of creates that asymptote. So I have negative 3. It's not included because it's never actually going to be right on the asymptote. Asymptotes are just things that we get closer and closer and closer to, but can never actually reach. It's like my dreams of going to be an astronaut. I'll try to reach it, but it's never going to come true. That's not actually one of my dreams. I'm lying to you. I'm lying even though I'm sitting down. All right, so last one, 3 over x plus 6. Remember, put your x plus 6, your entire denominator, inside that parentheses. You can graph it. You can see what the graph looks like. So it looks like it has moved to the left 6. Hey, that's what that plus 6 does. The 3 just multiplies the y's by 3, so it kind of stretches it out in the y direction. I don't know why I did it there. It stretches it out in the y direction. All right, so important thing for the domain and the range. For the domain, I have everything except for negative 6. If I put in a negative 6 into my denominator, I'd be dividing by 0. Not possible. I can't do it. You can't do it, man. It won't work. Right, so negative infinity to negative 6, or negative 6 to infinity. Those are my possible x values I can have. See, there's the Texan accent that came out. I don't know why. All right, so for our range, it has everything all the way up until 0, and then from 0 to infinity. Right, everything from negative infinity, oh, you couldn't see what I was looking at, from negative infinity to 0, where it will bottom out over there, and then 0 to infinity, so it goes out forever. You can graph these on Desmos as well. You can graph all these things in Desmos. Let me pull it up and show you. Desmos. Start graphing, fool. Yes. So y equals, what do we have? 3 over x plus 6. So 3 divided by, and Desmos does it for you, so that's kind of nice. X plus 6. So you don't have to worry about the parentheses. And then when we look at the graph, we can see it's going to 0. As it goes out forever, it's going up and down forever, left and right, except for that negative 6, and it's not touching at 0. All right, as always, please, 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 I'm here for you guys. Let me know how I can help you. See you soon.